Today's video is about air. Air is present in the atmosphere which surrounds the earth and extends up to 300 km above the earth's surface. So what are the composition of air? Air is a mixture of gases. So what are they? Nitrogen is 78% and oxygen 21%, and the other gases are 1%. So this is a pie chart which shows 78% of nitrogen and 21% of oxygen. So this is oxygen and this is nitrogen full. So the other 1% is there. That 1% other gases, what are they? Helium, neon, argon, krypton, then maybe carbon dioxide, carbon monoxide. So many gases are there. Next is the properties of air. Air occupies space. So when you blow a balloon, so it occupies and the balloon enlarges. Then air has weight. So it has weight also. Air is essential for burning. Air is a mixture of gases. That is, it has no definite properties. Since it's a mixture of gases, you don't have the specific property for air. It has carbon dioxide, water vapor, nitrogen. So all the gases are together. Next is oxygen. Oxygen was discovered by Joseph Priestley in 1774 and was named as oxygen by Anthony Lavoisier. Oxygen is the most abundant element on the earth. Occurs in water in combined state. 2/3 of the human body contains water. Even in plants and animals, it is found in a combined state. Then physical properties. Oxygen is a colorless, odorless and tasteless gas. Density of oxygen, it is slightly heavier than air. Solubility, oxygen is slightly soluble in water. Then because of this property, fishes and aquatic plants are therefore able to survive in water. Now nature, oxygen is a neutral gas. So it is neither acidic nor basic. So a moist blue litmus remains blue in color. So there is no change in the litmus paper. So next you find oxygen as oxides. So in the combined state you find as oxide. When an element, so what is an oxide? When an element, non-metal or a metal, burns in oxygen, the product formed on burning is called as an oxide. Example, sulfur burns in oxygen to give sulfur dioxide. That is, yes, sulfur, oxygen, burns in oxygen, it forms sulfur dioxide. Carbon burns in oxygen to form carbon dioxide. Carbon, C plus O2 gives you CO2. Phosphorus burns in oxygen to give phosphorus pentoxide. P plus 5O2 gives you P2O3. You have to balance the equation. Similarly with metals. So when potassium burns in oxygen, it gives you potassium oxide. K plus O2 gives you K2O. Sodium burns in oxygen to form sodium oxide. That is Na plus O2 gives you Na2O. Calcium burns in oxygen to give calcium oxide. Ca plus O2 gives you CaO. All metallic oxides are, that is generally all metallic oxides are basic oxides. They are known as basic in nature, so they are basic oxides. All non-metallic oxides are acidic in nature, so they are known as acidic oxides. For example, acidic oxide, sulfur, sulfur dioxide. Sulfur is a non-metal, so non-metallic oxide. When dissolved in water, it gives you sulfurous acid. Sulfurous acid means it's acidic in nature. Carbon dioxide, when it dissolves in water, gives you carbonic acid. That is also an acidic oxide. That is acidic in nature. Phosphorus pentoxide, when dissolved in water, gives you phosphoric acid. So all non-metallic oxides are acidic oxides. So acidic oxide, when dissolved in water, gives you acid. Similarly with metals, metallic oxide when dissolved in water, that is potassium oxide, when dissolved in water gives you potassium hydroxide. So hydroxide, all hydroxides are bases. Sodium oxide when dissolved in water, it gives you sodium hydroxide. And calcium, when calcium oxide reacts with water, that dissolves in water to give calcium hydroxide. This is also a base. Laboratory preparation of oxygen. The setup it is like that. So in this round bottom flask, manganese dioxide is taken, and through the thistle funnel above, hydrogen peroxide is added dropwise, and due to the decomposition of hydrogen peroxide, oxygen is collected in this the delivery tube, and it is collected in the gas jar. Next is uses of oxygen. Oxygen is slightly soluble in water. So this dissolved oxygen is utilized by aquatic creatures for respiration. All animals, including human beings, need oxygen for respiration. Oxygen cylinders are carried by sea divers for respiration. Patients in hospitals need oxygen for respiration, that is for artificial respiration. For burning, oxygen is needed. Oxyacetylene flame is used for welding purpose. It produces a high temperature of 3000 degrees Celsius, which is used for cutting and welding of metals.